Hey guys, we have 11.6 here. It's absolute convergence. And ratio and root test. Okay, so three things: absolute convergence, ratio, root test. So if is convergent, then we say is absolutely convergent. If AN is absolutely convergent, then it is convergent. I know it's a little confusing, okay, but that's why we do exercise, okay? Now, the ratio test. I assume you read the book. Limit n goes infinite. Absolute value of A is, say this is L. Let's say this is L. Number one, if L is less than 1, then the series is absolutely convergent. So convergent. If L is bigger than 1, including infinite, then the series divergent. Number 3, if L is equal to 1, no conclusion. No conclusion. No conclusion means you got to use different tests. Okay, that is called what? Like the name says, ratio test. Okay, what is root test? Same thing almost. Limit n goes infinite. Nth root of an. Okay, let this equal to L. And then same thing. If L is less than 1, absolutely convergent. If L is greater than 1, including infinite, then AN divergent. 3, if L equal 1, no conclusion. Okay, all right, so let's do some exercise here. Very easy. You guys all got an A in the test. I don't know how. Well, get number 1. Exercise number 1. What can you say about this series? Okay, so A, limit n goes infinite, an plus 1 over an. This is equal to, say, 8, meaning bigger than 1. That means the series divergent. Okay. B, limit n goes infinite, an plus 1 over an is 0.8, which is less than 1, then absolutely convergent. So convergent, okay? C says what? Limit n goes infinite, an plus 1, an equal to 1, no conclusion. Okay, right, so that's number 1, and man, it's pretty easy. Okay, let's do number 3. Number 3. Now, so whether absolute conversion or conditionally conversion, okay? What is conditional conversion? Meaning, summation of an conversion, but summation of an diversion. We call conditional conversion, okay? Remember that. That is conditional conversion, okay? Let's go number 3. Summation of n equal 1 to infinite, negative 1 to n, 5n plus 1. This guy is conversion. Okay, you check it by what? Alternating series. Okay, test. But look at that. But what am I saying? But okay, but summation of an is summation of 1 over 5n plus 1. Okay, then this guy is conversion or divergent. This is not alternating. Okay, now this is what you're going to do. Okay, this is how are we going to do this one? Is it conversion or diversion? Okay, to do that, this is let's do limit comparison. Let's do limit comparison test. Okay, now, so if I call this an, and then 1 over n, I'm going to call this bn. So bn is divergent, harmonic. Okay, so limit n goes infinite, an over bn. Remember this one? This is limit n goes infinite, 1 over 5n plus 1 over 1 over n, which is limit n goes infinite, n over 5n plus 1. Okay, this is 1 over 5 plus 1 over n, which is 1 over 5, is less than 1. Okay, since summation of 1 over n is divergent, summation of n over, summation of 1 over 5n plus 1 is also divergent by what? Limit comparison test. Okay, it's called limit comparison test. Okay, all right, so that is number 3. Very nice question. Okay, I hope you like it. Let's go number 5. So in other words, so because it is convergent but not absolutely, so this guy, so conclusion is conditional conversion. Okay, conditional. That's what they want you to say. Conditional conversion. Okay, this guy is conditional conversion. Okay, number 5. Summation of n equal 1 to infinite. It is sine n over 2n. Okay. Now, let's call this an. Then sine n over 2n is less than. Okay. If I call sine n over 2n. Okay. What is the meaning of that? Summation of an, absolute value. Okay. Is less than 1 over 2 to the n because sine n is less than 1. Okay, this is 1 over 2n. This is conversion. Okay, by geometric. Okay, all right. Let me see. So, okay, so now, so the conversion now, so because this is less than this guy, this is less than this, this is conversion. Okay, okay, absolutely. So conversion. Okay, all right, next one. Okay, now let's go to number 7. Okay, number 7. So number 7 is ratio test. Use ratio test. Okay, now, so summation of n over 5n. Okay, usually, you can say n equal 1. It's always infinite. Okay, so now, so from here, what is an plus 1 over an? Okay, what I'm saying is, I have to say still limit. Okay, so limit n goes infinite, an plus 1 over an. Okay, so that means limit n goes infinite. Now, n plus 1 over 5 n plus 1 times 5n and then n. All right. Everything is positive, so I don't need to put absolute value. So limit n goes infinite. Now see what I do here. N plus 1 over n, 5n, 5 times 5n, okay? This is 5, 1 over 5, limit n goes infinite, 1 plus 1 over n over 1, 5n cancel, so this is 1 over 5 less than 1. So what is it? Absolute conversion. Okay. Okay. So let's go to number 11. What is number 11? 11 is summation k equal 1 to infinite 1 over k factorial. Okay, then what is limit n goes infinite a n plus 1 over a n? That is limit n goes infinite 1 over k plus 1 factorial over 1 over k factorial. Basically, that's what it is, okay? So this is limit n goes, or not n, but this is, I should say, k. Is that right? Okay. But you know what I'm talking about, right? So this is k, k. So this is, let's change to k, right? K goes infinite. So now this is k factorial over k plus 1 factorial, which is limit n goes infinite. This is 1 to all the way to k. This is a 1 to all the way to k, and we got one more, k plus 1. Okay. So this is, come on, man. So this is limit k infinite 1 over k plus 1. This is n, okay, which is 1 over infinite, 0, less than 1. Okay, so it is convergent. Okay, what kind of convergent? Absolute. Okay, all right, let's do the next one. How about 13? Okay, now the 13 says summation n equal 1 to infinite 10 to the n plus 1, or, oh my god, this is so confusing, right? Okay, so that's the question. Okay, okay, then limit n goes infinite a n plus 1 over a n is limit n goes infinite 10 to the n plus 1 over n plus 2, 4 to the 2n plus 3, 4 to the 2n plus 1 plus 1. That's what I mean. 4 to the 2n plus 2 plus 1, okay? So now, over, so this is 10 to the n go here, n plus 1 here, 4 to the 2n plus 1, okay? Well, everything positive, I don't need to put. So this is, again, limit n goes infinite. Now here, 10n plus 1 over 10n, the first one. And then n plus 1, n plus 2. You put the like terms together. That's what I'm trying to do, man. 2n plus 1, go to the 2n plus 1 times 4 square, okay, here. So this is limit n goes infinite. Here, this is 10. This is everything canceled to 1 over 16, which is 10 over 16, which is 5 over 8. Hey, less than 1. Okay, so absolute conversion. Okay. Okay. Some people want me to write every answer. You gotta use you have to do your own. I mean, there has to be a limit. I cannot do everything. It's okay. N equal 1. Okay. N pi n over -3 n minus 1. Oh, well. Okay. So now from here, what is limit n goes infinite a n plus 1 over a n? Because we put absolute value, all the negative disappears. So limit n goes infinite, n plus 1 pi n plus 1, all the n becomes n plus 1. 3 n minus 1 plus 1, oh my god, do I have to write that? Over 3 n minus 1 n pi n, okay? That's the first thing you have to write. Equal to limit n goes infinite. Now see here, I'm putting together n plus 1 over n. What do you think? 3n minus 1 over what? 3. And then pi n plus 1 over pi n. All right? So this is limit n goes infinite. This becomes 1. This becomes 1 over, what is it? 3n. Sorry about that. Okay? And then this is what? Pi. Okay? So this is, oh my god, pi over 3. This is 3.14 bigger than 1. So that means the series is divergent. Okay? What is the series? This one I'm talking about. Okay, next one. Okay, and then let's try, what is it? Number 19? You do 19. Okay, here, 19 almost same. Okay, 21. 21 is, oh my god, give me a break, man. Okay, so 1 minus 2 factorial, 1 times 3 plus blah blah blah. At the end, negative 1 and minus 1, and then n factorial over, and then what is it? 1, 3, 5, blah 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 blah, 2n minus 1. Okay. So now, what is this case? An limit n goes infinite, an plus 1 over an. In this case, it is limit n goes infinite. Now, what is a? So this is very interesting. This is what it is. This is n plus 1 factorial. 1, 3, 5, 2n minus 1, 2n plus 1. Okay, this is n factorial, 1, 3, 5, 2n minus 1. Okay, so that's what it is. So now, as you can see, they all cancel up to here. They all cancel. Cancel, what's left? N plus 1 left. So this is equal to limit n goes infinite. What's left? N plus 1 over what? 2n plus 1, which is 1 plus 1 over n over 2 plus 1 over n, which is 1/2 less than 1, absolute conversion. Okay. Okay, that's 21. What's 21? Ooh, you do that, 21, almost same. No, I just did 21, didn't I? Yeah, I just did 21. Okay, let's do, try 23? Sure, 23. Okay, so 23 is summation of n equal 1 to infinite, and then what is that? 2, 4, 6, blah, 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 2n. What is that? N factorial. Okay, so limit n goes infinite, and I just put definition, I mean absolute because that's the definition. Okay, limit n goes infinite. Here, what is, acting up again, this stupid, I hate this. Gotta be some way to stop this. I don't know. This technology is not very good. Okay, here. Okay, so 2, 4, 6, blah, 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 2n. And then we have to one more term. What is it? 2n plus 2, isn't it? The difference is 2. And denominator is n plus 1 factorial. And then this becomes n factorial. And then 2, 4, 6, 2n. Okay, so now we got a lot of cancellation to do. So you got all this cancel with this. This disappeared, that disappeared. What's left? n plus 1 left. So this is basically what? N plus 1 less than 0, because limit n goes infinite. I mean, infinite. So it is actually equal to 0. Okay, equal to 0. Okay, so less than 1. So conversion. Okay. All right. Okay, that's up to 23, and let's do 25. That's a root test. It's different test. Okay. Here, root test 25 is a root test. Root test. Remember root test. Limit n goes infinite. N root of a n. Okay. We're checking this one. 25. So summation of n equal 1 to infinite. What is it? N squared plus 1 over 2n squared plus 1 to the nth power. So that means limit n goes infinite, nth root of a n, because nth root, this is goes infinite, n squared plus 1 over 2n squared plus 1. That's what it is. Okay. So which is actually 1/2, less than 1. Absolute conversion. Okay. All right. Okay, that's 25 and 27. Summation n equal 2 to infinite, and then negative 1 n minus 1 over ln n to the n. Okay, actually the root test, you gotta put absolute value. Okay, so absolute value. So we want to make everything, you can have a negative inside the radical. So from here, limit n goes infinite, nth root of a n is limit n goes infinite ln of n. Okay, that's what it is, which it is infinite. It's bigger than, so it is divergent. Okay, divergent. Now, so this guy is divergent, but this is a very interesting question, but this is self, whole thing, but summation of this is an. An is conversion. Why? Because alternating series. Okay. Okay. Therefore, it is what kind of conversion? Conditionally conversion. Okay. This guy is divergent. When you put absolute value, divergent. But the series itself is conversion because it's alternating. Then we say the series is conditionally conversion. Okay, that's 27. Let's do 29. You want to try 29? Okay. 29. 29. So 29. 29 is summation of n equal 1 to infinite 1 plus 1 over n squared. Okay, so limit n goes infinite nth root of, you know what is the meaning of this one? This is 1 plus 1 over n times n. Okay, so if I have 1 plus 1 over n times n, 1 is cancelled. So this is limit n goes infinite 1 plus 1 over n to the n. This is the definition of what? You calculus student, okay? Definition of E. But so this is bigger than 1. Therefore, diversion. Okay? Very good question. That is 29. Let's do, might as well do a little bit more. I do everything for you. Doesn't mean tests are going to come out here, man. It's going to be similar. Okay, use any test. Use any test, okay? Any test. So, summation of n equal to infinite, -1 to n over ln of n, right? Now, this is a very good question, okay? Definitely, this is conversion, okay? Conversion by what? Alternating, okay? But conversion, absolutely? That is the question. So to check this one, summation n equal to infinite, 1 over ln of n. Okay. Now, so how this one is conversion? Okay. So now, what test are you going to use? So I'm going to use comparison test. Okay. Comparison. Let's use comparison. Now, to use comparison test, you got to find something compare. So if I call this an, I'm going to call 1 over n bn. Okay? Now, log n and bn, which one is, log n and n, which one is bigger? This is bigger, man. Here. This is n. This is log x. This is x. Okay, this is y equal x. This is y equal log x. X, this is bigger than log x. That's what I mean. Okay, so n is bigger than ln of n is bigger than 1 of n. Okay? 3 is less than 5, then 1/3 is greater than 1/5. Okay? So here, this is bigger than 1 of n. But summation of 1 over n is diversion. Okay? Then 1 over ln of n is also diversion. Okay? So finally, what's the conclusion? The series and ln n summation is what? Conditional conversion. Okay, very good question. Okay, next one, 33. Might as well do everything. 33. Okay, summation n equal 1 to infinite. How about -9 to the n, and then n times 10 to the n plus 1, okay? So now, limit n goes infinite. Now, I'm going to use, let me think. I'm going to use a ratio test, okay? A n plus 1 over a n, which is limit n goes infinite, 9n plus 1, negative all disappears, n plus 1, 10, n plus 2, and then n, 10, n plus 1, 9 to the n, okay? So now this is limit n goes infinite, 9n plus 1 over 9n, and then n plus 1, and then 10n plus 1 over 10n plus 2. Okay, so this is 1 over 9. This becomes 1. It is, 1 over, yes. Oh, this is not 1 over 9. This is 9, okay? Because, look at this. This is 9, and then 1 over 10, which is 9 over 10, which is 0.9, which is less than 1. So, absolute conversion, okay? All right. And then the last one, let's try. Oops, what are you doing, man? I'm not asking you that. Let's do 35. Okay, summation n equal 2 to infinite, n ln n to the n power. Okay, so limit n goes infinite, nth root of an. This is limit n goes infinite, n over ln of n. Ooh, this is infinite over infinite. Okay, so I use L'Hopital, which is 1 over n, which is n, which is infinite. So Thai version. Okay, by what? Root test. I'm all done, man. That's it. Well, let's try. What the heck? 37. I don't think I assigned 37, but 37, I think you can do it. 37 is summation n equal 1 to infinite, negative 1. What is it? Arctangent, or I hate arctangent. Someone is a tangent inverse of n over n squared. Okay, now remember, if I say limit n goes to infinite an, this whole thing is an, okay? Then this is limit n goes infinite, tangent inverse of 1n squared. Now tangent inverse when n goes infinite, so this is less than equal to pi over 2 over n squared. Okay. What is the tangent inverse of infinite? This is pi over 2, man. Tangent pi over 2 is infinite, okay? Hey, remember that. But limit, yeah, but summation pi over 2 over n squared is pi over 2 summation 1 over n squared This is a conversion. Okay. Okay. P series. Because this guy is P equal 2. Therefore, tangent inverse of n square conversion? Absolutely. Okay, that's the end of it. Thank you very much. Go and study.